And our next speaker is Mark Lambert from Advantech Wireless.
Thank you, everybody. Thank you, Simon and Julian. So I'm going to talk about what Advantech Wireless is doing in the area of next-generation broadcast networks. And we've spoken about all of the different ways of delivering that are coming through, the delivery over IP, etc. But actually, I'm going to speak about the ways that we've delivered television for quite a while over satellite and the innovation that's required there, because we've been making a lot of developments and advances in certain areas, but other areas have really been holding that back. And Advantech and some other organizations have been trying to innovate and to push forward in that area. Before I get onto the detail, though, I know a lot of people have seen me present at these things before around the world. And I've told you about the way that at those events I've mentioned that I've been asking my daughter for tips on presentation skills. And she's been coming through her teenage years and developing her presentation skills. And so last night, she's about 17 now, and last night I was speaking to her on the telephone and I said, you know, your dad's got this presentation tomorrow, we've got to try and keep it short, 15 minutes, etc. Any ideas? She said, Dad, I'm 17 now. Honestly, you can't keep coming to me for these tips on presentation skills. You're going to have to fly by yourself. So today, unfortunately, unsupported, let's see how it goes. But move on and look at who Advantech are briefly. We're all about smarter solutions. And we've got a variety of different technologies. As I say, I'm going to focus on a particular area today. But in each case, it's looking at where the problems lie and trying to develop solutions that actually solve those problems. So, smarter solutions. And a global reach. You know, I know a lot of people are working worldwide, but we are literally delivering into pretty much every part of the world, and particularly those remote areas where satellite does so well because it's so difficult to serve. Along the way, we've won a number of awards. I'm not going to go through all of these in detail, but suffice to say we have had some supporters that have kindly recognized what we're doing and given us various awards for our technology and our innovation. So, direct-to-home television. We could say that we're in the second generation. We've pushed forward with various encoding technologies. DVB-S2, we've had that for, I think, the first DVB-S2 distribution network, which was installed by Advantech, first in the world, was, I looked yesterday, 11 years ago. And so we've been delivering television via DVB-S2 for 11 years. Fantastic. We've looked at different ways of reducing costs, etc. But it really is a fast-growing communication segment. And there have been various challenges along the way. In fact, I would say the success of DVB-S2, the success of various encoding technologies, etc., we've been holding them back. If I look at the way that we're actually getting the signal out there in many cases, we're still going through klystrons and TWTs, and they're not up to the job of delivering these DVB-S2 carriers at higher modulation schemes with really lightweight error correction. So we sort of need to get over that. Now, I mentioned Advantech Wireless. We've got technologies coming in all of the various areas of satellite communication and also microwave. And I could speak all day about these technologies. I'm really, really passionate about it. But I'm not going to take all of your time on this. A little bit later, there are some slides on some of the details of the technology. I'm going to skip through those because you can download the content. You can watch this back on the web later. So let me keep it short. Let me keep to the gist of the presentation. But suffice to say, we have everything from the antennas and the controllers through the multi-service VSAT platforms, through the point-to-point microwave, through the amplifiers, the one-stop shop. I thought probably the best thing that we could do is to actually look at a case study. Let's not focus too much on all of the different technology, but let's look at a case study as to what we did recently for a customer. I'm not going to go into too much detail about where they are in the world, but basically they had an issue of wanting to develop and to deploy a new direct-to-home satellite television service. And they got all of the usual challenges that involved. They wanted to do this in extended KU. It's quite a rainy part of the world where they are, so that's a challenge in itself. They had got themselves about 1.5 gigahertz of channels that they wanted to put out over there. They talked SES into launching a satellite that they could use, specifically or almost entirely for this service. But it always comes down to cost. And I think we've already mentioned it. Simon mentioned the word many times earlier, words such as monetization, economic situation. We can look at all of these technologies, but it's coming down to cost. How can we deliver this cost effectively? Because we're less certain as to who's watching, and we're less certain as to which of those routes that they're watching through. So it's both television delivery and IP delivery. These guys wanted to deliver IP via the same satellites as well. So they basically had a dilemma. Do they use the traditional way of doing it? Do they go and build a similar Earth station to all of the other Earth stations that have been built over the last 40 years or so? Each of those multiplexers for the TV channels is going through a separate klystron, and then you bring them all together and you combine it and put it out over that antenna. Or do they try and do it more cost effectively, do it differently? Do they stay in the comfort zone, or do they take a gamble in their eyes? Well, today, staying in the comfort zone can be deadly, so we set out trying to convince them that actually they should take that gamble, the gamble being to move towards some new technologies. As I say, I can then talk endlessly about the actual technologies. I'm not going to go through this in detail, so I'm going to skip through the next 10 slides or so, which you can look at your leisure when you download a copy of the presentation. Talk about gallium nitride amplifiers, which is something we introduced 4 or 5 years ago. And they've got a lot of benefits in terms of size and weight, really reducing down the equipment that you need, or the size and the weight of that equipment. And they're super linear, so they're fantastic for putting those high order modulation schemes through. But as we said earlier, it really comes down to the money. And so if I get to, I think, this slide, we start to talk about the money. The way that they thought about doing it, klystrons, TWTs, we calculated that probably they were going to spend at least $10 million just on the klystrons themselves, and then you need to, klystrons are an indoor technology, you're going to need to build a shelter, you're going to need to air condition it, you're going to need to spend money on maintenance, etc. It all really adds up. And we set off saying, okay, well, with our gallium nitride, firstly, you can live outdoors, you can put it up next to the antenna, you're not going to have the loss that you have with klystrons, you can put all of the carriers through the same amplifiers, so you combine it at the L band, which is much more efficient, put it through those amplifiers, a lot less loss between the amplifiers and the antenna. It's fantastic. Still, they needed a little bit of convincing. We had more work to do. So we said, okay, let's sketch this out for you. Let's look at the equipment. As we said, if you add in those shelters, etc., we reckon they were going to need to invest about $12 million US to build this uplink site, and its redundant spare. We said, okay, we can do it you for $5 million. We can deliver all of the Earth station equipment for roughly about that $5 million mark. Okay, they said. Let's look at how much satellite capacity you're going to need. Previously, if you build it the traditional manner, you're not going to be able to run all of those higher order DVB-S2 modulation schemes that you really want to do. So you're going to need about $43 million worth of satellite bandwidth, approximately. If you can use those more efficient techniques, you're going to be able to approximately halve that down at, let's say, $24 million a year. Electricity. Well, if you're looking at electricity prices in the US or somewhere similar, for this type of installation, you are actually talking probably $600,000 a year just in paying the electricity bill. It's really, really expensive business. And if instead you were putting this in Europe, it wasn't in Europe, but if you were paying European prices, that's going to be more like $2 million per year in energy costs. And we're supposed to be green these days. We're not supposed to be spending all of this money on energy. So we said, okay, more efficient gallium nitride, you're going to be able to run this system for around about $100,000 a year to the electricity company. They quite like that. Maintenance. Well, if you look at 5% approximately maintenance costs, that's what we usually work on in these industries. If you're spending $10 million on the equipment, it's going to be about $500,000 a year just on maintaining it. If you spend a lot less on the equipment, say half that, then it's going to be about half the cost in maintenance. Let's summarize. So we said to them, look, buy the equipment, you're going to have a reduction of about 45% in costs on the equipment. And this was the clincher. Said, look at the lifetime costs. This is going to cost you the traditional way just over $450 million over the lifetime of the project. How does $250 million sound? They were sold at that point. There it is. We installed it about 18 months ago. It's got a sister antenna not far away that is just for backup purposes. We've supplied the antenna. You can see the amplifiers at the back of it on the platform there. It's our antenna controller, making sure that it's accurately pointed at the satellite. It's I think that one's a 13-meter extended KU antenna. They love it. It's still something that they talk about on a regular basis. They are now a customer that we can take to anybody else in the world. In fact, I think they're a bit tired of that, but they very, very much are a reference customer, and it's been a great success. So that brings me to the end of my presentation. If you would like to know a little more, happy to answer questions now, or come on down to Hall 1. We're on booth A74, just inside the door. But otherwise, thank you very much. Anva, a question.
Wait for the microphone.
Thank you. It doesn't make much difference to the overall business case, but could I just challenge you on the maintenance costs? Because surely, unless you're only maintaining it half as often, then the costs are going to be half the traditional. Why are they so different? I mean, as I say, overall in a business case, it doesn't matter that much, but I just don't see, you still got to get a man or a woman to go out to do the thing. There's a cost in that, and that doesn't matter what you're using.
I agree, but in terms of shipping, of taking the man or the woman, yes. If he needs or she needs to go less often, less cost. Is that true? That's what I was asking. It is true with, I mean, we've been delivering gallium nitride systems for 5 years now. I got endless amounts of field data that show that the mean time between failure of these systems is absolutely huge. You know, definitely, these are much, much more reliable technologies than we've had previously. And there's no need to replace them as we did previously with tubes as they died off. You know, the solid state solution keeps on going for the lifetime of the project. And generally, the cost of those spare components, etc., is, apart from not needing them as often, is also dramatically reduced because you're not having to go out and regularly replace those tubes. You might have a power supply go or something like that here and there, but generally it is literally lower spares costs as well.
Thanks. That answers my question for you.
Thank you.